Dr. Lomiento and Dr. Salem. This is Ganuni. I'm trying to present to you everything that I did for my link model. I'll start off with the loading profile. I uploaded this graph from the sample that I created. And here you can read that the time step is the hundredth of a second and the displacement is shown in inches. And this is directly the applied profile that I used in my ANSYS profile. And from there I called it 15-second Ganuni text file import that I'm gonna use later on to define the rest of the loading profile. I'm going to show you the properties of the columns that I used just to make sure that there was no mistake made. On the top it's an 18-inch square that's the outside diameter, and the flash thick this is 1 inch thick, just to show you what section properties are. You can see it here. And then the 24-inch outside diameter pipe, also 1 inch thick. This, it may not be accurate to what is out there on the field, but it is exactly what I used in my ANSYS file. And here we see the properties in the stiffness file. As I was playing around with the model, I modified it, modified the torsional constant, and now I set it back to 1. And now I'm going to show you how the model looks. Basically it's a small 6 inches tall profile. I didn't want deflections to come into play, and whatever deflections we did see, I wanted to make sure that the solution time was small, so whatever is visible here is actually similar to the model that I have in ANSYS. Now I go to the link properties. Ignore the damper, I created it at the end just to see if it would make any difference. The hook, most important attribute of the hook is that I'm gonna set a very high effective stiffness. I'm gonna change all my stiffnesses to 10,000 kip to allow a very small deformation vertically. And obviously the hook kicks in at 1.75 inches away from the center. Same thing with the gap, 1.75 inches from the center is going to kick in, and the distance from end J is 0.5, so it's at 50% distance. Now we go to the friction, and it's actually a tension compression friction isolator that was modified per Dr. Lomento's suggestion. I'm gonna set a pretty high effective stiffness. I'll change the damper as well, but as I said, I'll set the compression and tension to 10,000, leaving no gaps between the tension and compression and where it kicks in. I'm going to change all of the nonlinear property stiffnesses to 10,000. And I don't know if it makes a difference, but the effective damping I'm going to change to 5%. The friction coefficient I'm going to change to 0.1, and just so that when whatever vertical load I'm applying is going to be easily predicted whenever I'm looking at what kind of a friction effect I'm gonna have whenever I'm moving my columns laterally. So for 10,000 pounds vertical force, I'm expected to have I'm expected to have 1,000 pounds of reaction force. And here I'm showing that I have the friction isolator, the hook, and the gap installed between the two columns. Next, I'm going to talk about what kind of restrictions I have, restraints on the joints. So I'm going to show that on the top joint I've only restrained it from movement in the X direction. That's because I'm going to apply a G load pattern displacement, and that's seen in the displacement in the X direction. And also I'm applying a negative 10 kip load, vertical dead load. When I move on to the pins, the joints that are connected to my links, I'm just restraining the rotation. So you can see that in both of the joints I have restricted the rotation. Okay. Here I think I double click it just to show you that for some reason I saw the translation was restricted, so I just wanted to redefine it, but we see that nothing changes. We still only restrict the rotation. Same thing here. So anything that the links touch have only rotational displacement restricted, and at the base I have restricted everything, the translation and the rotation, about all axes. Next we're gonna get into the load patterns. So we go to the load cases. First I have the dead load, and here I showed just all of the properties I selected for it. It's a static case with a nonlinear effect selected just in case later on I choose any nonlinear properties, and shows the degrees of freedom. I don't know if you noticed the U3 direction was selected, and I left everything else standard. Now we get into my nonlinear loading pattern. You see that the 15-second text file load function was chosen. It's nonlinear direct integration time history load case. Because it is 15 seconds and each step is 100th of a second, I chose 15,000 output steps. 1500 output steps. The rest of the materials I left the same, the rest of the information I left the same except for damping. And now we're going to run the dead load first, and then we'll use that result to run the time history analysis. And here's where I noticed that I'm looking at the wrong plane. So as soon as I chose, I checked just to make sure that the dead load is acting properly. And I see that both columns are compressing, and obviously we see change in the vertical position, so indicating vertical deflection. Not deflection, compression. And this is one of the problems I'm having. You'll see now that I will try to go step by step and show you how the model is jumping. When you animate it, you see that everything is smooth, but for some reason it's dancing in the middle while the top and the bottom aren't moving. But here, notice how much it jumps back, and I'm moving every time step one after another. There's no jumping in my ANSYS file, in my ANSYS solution. everything is smooth, the transitions are smooth, but here in SAP we see this jittery back and forth effect that's captured in our output. And when we look at the display, at first it's very difficult to tell, but when we zoom in, so for the first 6 seconds we don't notice any of those spikes. So I'm going to limit the graph to 6 seconds. And here we see first of all that the resultant loads are very small and that they appear to happen at very high frequency, so indicating a very small period. It's one of the problems I'm having. If you have any idea what I did wrong, I would really appreciate your input, and that'll be it. Thank you.